So this is exercise 13.5. Let's just get it done real fast. So first question, right? The first question. So what for question 1 and 2? Write A in the form of acceleration. So acceleration equal to ATT plus. Okay, without finding T and N. What do you mean without finding T and N? That's kind of weird. How can I do it without finding T and N? The acceleration is what? No, that doesn't even make sense. Not finding. Okay, I see. Because so whatever eight. So this component, if your acceleration is something like a tangential plus a normal, then what happens is, so since tangential is like so multiply this by v, so this just becomes like at, and then the magnitude of v basically. Normal component is 0. So what does that mean? Your a tangential is just like the dot product between a and v. Yes. So you can just find the velocity and then take a dot product, and that's going to be okay. Sure. But then again, you can rewrite this. So I think I've seen this somewhere, right? So this thing is just dv by dt times v. So what is v dot dv? Well, that thing is just the magnitude. So this thing is exactly just 1 by 2 d by dt of v squared, right? So basically the yeah, right. Oh, okay, this and this upon, so this stuff, right? So all of that and that times 1 upon v basically, I suppose. Yes, is that the correct thing? I think so. So just taking dot product will be right. So 1 by v over there with the initial acceleration times this stuff. There's got to be some way to be doing this. Well, you can think of it as the square root of v equals to, okay. So you can just think of this v as the quantity. So then this whole thing just turns out to be like v dv by dt times 1 by v, which is just this. So it's basically the rate of change of speed, right? Yeah, so the tangential acceleration is just like d magnitude of v upon dt. So that's all we need. Now I'm thinking, is there a better way to be writing this? I guess we can probably write it as a better thing. How about like dv by dx and all that? Never mind, this is probably the best way. So the tangential acceleration is just that. Okay, and then once we have that, we can figure out what the normal acceleration will be, right? So the normal acceleration, what about taking a cross product with velocity? Probably won't work that much. So without knowing what t is, this is almost not going to work, like guaranteed. So how do I find normal? So it's just everything that is not in the tangential direction. Okay, what would that be? Well, I have no idea. I really have no idea. Think about it. So it's just a minus a t. That's what this thing is. Okay, how do I use the normal component? Well, what about the binomial vector? Not really going to do anything, isn't that right? How do I do it without finding t? Now it's making sense suddenly. Without, so is there like some sort of a rule which I can use? So there's this stuff, t and n and all that. Acceleration, tangential, yeah, sure. Oh, okay, so there is a way to be doing this. So okay, this is something which we derived, and then this kappa magnitude of v squared. Okay, so once you calculate what velocity vector is, you can calculate your kappa as this thing, the magnitude of v cross a upon the magnitude of v cubed, and so you're saying that times of magnitude of v squared, which is just this stuff. So that will be your okay, not bad. So you can calculate the acceleration, you can calculate your v vector, and so this is going to give you the thing v cross a upon magnitude of v. Extremely weird, but sure, I guess so. So it's actually not that bad. I mean, you just have a equal to a tangential tangential plus a normal normal. So then you just take a cross product of that with velocity vector, but then t is correlated with it. So all you get is like a vector cross v vector, or you could do the left hand thing first. So it's just v vector cross a vector. That thing would just be equal to a n and then v vector cross n vector, but then you take a magnitude of that and then you realize that these two are perpendicular, so then this is the magnitudes multiplied. So a n magnitude of v, over here you just have magnitude of v cross a, so a n is just equal to what we wrote down. Sure, this is okay. Okay, cool. So that much is clear. Let's go to the next thing. Just a second. Okay, so let's just start. So all we just need to do is figure out what a is going to be, right? The acceleration. Yeah, and that should pretty much give us everything. So what is this stuff? What's the velocity? The velocity is a cosine t sine t. It's like, okay, negative a sine t, and then you got a cosine t, and this thing is bt, so just this thing is b. Sure, your acceleration would just be equal to, call it a vector. That's just going to be equal to minus a cosine comma minus a sine, and yes, and this thing is 0, right? So your v cross a, that is what? So this thing is negative a sine a cosine b, and then that crossed with negative a cosine negative a sine, and then 0, which is going to be, so that thing is 0. Sure. Yeah, I know this, there's a better way to be doing all of this, but just do it in normal organic way. So this is just minus 1, this is like plus, so just abs, then so for this thing it's just b, so negative bac, then plus, so plus a square s. Shit, no, that's 0, so it's not going to be. What about this one? So a square s square plus a square c square, so that's just a square, right? So that's your v cross a. So you want the magnitude of that. Let's see if this simplifies. So this thing is just a, and then you got bs, and or you could just take the a b thing common, and never mind. Then you got minus b cosine and then a over here. So what you're essentially getting at is just so that just implies a square root of b square plus a square. That's okay. So that's your acceleration. Just a square root of b square plus a square, right? The norm of that. Sure. What about the norm of velocity? That's just equal to the square root of a square plus b square, which means this thing is just a. Yeah, sure. Okay. What else did we want? We wanted the, so you have the kn thing directly. So an is just equal to a. What about the a tangential? So your v is this stuff. The magnitude of v, we already figured out, it's just a square plus b square. It's constant. What does that mean? Tangential is just 0. Okay, next. The second question is the same stuff, except you have 1 plus 3t and all that stuff. So the velocity is just what? It's 3 comma 1 comma minus 3. Your acceleration is just 0. Oh wow, that's amazing. So it's just 0 comma 0. Aha, that was something. Yep, completely 0 comma 0. What else? There's no acceleration at all. Okay, question 2. That's done. Okay, question 3. 3 to 6, write a in the form a, okay, whatever, of t without finding t and n. Okay, so at some small t value. Sure, no big deal. So first we just got the velocity, that's equal to 1 comma 2 comma 2t, right? So your acceleration is going to be like 0 0, what is this stuff, 2, right? Take a dot product, what do you get? Just get like a dot v, that's equal to what? It's equal to like a tangential and then the magnitude of v. So basically it's just, oh, that it's pretty much just finding that stuff. I mean, you could have just figured out the tangential directly. So essentially you are finding the tangential, like that's pretty much the only way to do it. You know what, okay, never mind. So calculate the magnitude. So your magnetic velocity, that's just going to be like square root of 1 plus 4 5 5 plus 4 t square, and you get derivative of that stuff, so just 2 square root of 5 plus 4 t square, and then you got like 8 t, so this just cancels, just get 4, right? So you got your 8 tangential. 8 tangential is just equal to 4t upon square root of 5 plus t square, 4t square, sorry. And then your a normal, that is going to be like what? So v cross a, take cross product, that stuff. So this is 0 0, so k cross, well, let's do it with 0. So this thing is 1 2 2. So cross with I, you get j. So this is 2, and cross with j, you get minus I. Sorry for that. Or was it opposite? So you're doing v cross that, right? So it should be negative over here. This thing is negative, and so yeah, that's positive, so that's 4. Okay, so the magnitude of v cross a, that is going to be equal to 2 square root of 5. So what's magnitude of v? That is this stuff, so just have 2 square root of 5 upon square root of 5 plus, or oh, you have to have the 14, don't you? So it's 8 square root of 5 over there, 8 square root of 5 t upon 5 plus 4 t square. Amazing. Next, third done. Fourth, let's go. Fourth question is, once again you're given some r, so the velocity will just be like what? T cosine t, t sine t, t square, whatever. So velocity will just be like minus t sine, and then take a derivative of the cosine, just plus cosine, and then this thing is what was I doing? Minus t, not minus t, just t cosine and plus sine, and then this stuff is 2t. Okay, the acceleration is just what, like what, take a derivative, that's it, which is minus sine, and then that's minus sine over there. What the hell, that doesn't even make sense, does it? Minus sine over there, I mean, that's the thing, sure. So just like what, minus t cosine, and then minus sine plus cosine, or whatever. Okay, whatever. So what about this stuff? It's just cosine plus cosine, so 2 cosine. Yeah, something is really messed up about all of this, isn't it? Why do you get a plus cosine suddenly? Hey, it shouldn't be a plus cosine, it should be a minus sine over there, so it's minus 2 sine. This thing is a 2 cosine because the cosine over there and the cosine over there. Then you can derivative like this minus t times of sine, and this thing is 2. Okay, so you want to calculate this at t equal to what? 0, right? So you just have v is equal to 1 comma, this is gone, so 0, and then you got 0 as well. Okay, and then the acceleration is just, that thing is 0, that thing is 0, so 0, and then all of that is 0, and then 2. Sure. So your tangential acceleration is just like, well, this is already normalized, so it's also the t vector, so at is just equal to 0. The a normal thing is equal to the magnitude of v plus, and just now just 8 times of v, so just 1 times of 2 upon 1, which is just 2, right? So at equal to 0, a n equal to 2, sure, whatever. Next, fourth, fifth is r of t is some bizarre quantity, whatever the velocity is just 2t comma 1 plus t square comma 1 minus t square, right? The acceleration would just be equal to what, right? And we are doing it at t equal to 0, so basically your velocity just turns out to be this, and acceleration just turns out to be 2 comma 0 comma 0. Sure, the same as before. Your tangential component is just not there, your normal component is completely there. So normal component is just 2, so at equal to 0, a n equal to 2. I have no idea why you want to be doing this. Sure, the next thing, sixth is r of t is this stuff. Once again, what's the velocity? The velocity is just, no, it's gonna be some, never mind, just do it. So it's what, e power t cosine, then minus e power t sine, come on, e power t cosine, e power t sine, comma, well, so this thing is just square root of t power t once again. And the acceleration would be just, so just the same stuff, c minus s, and then plus the derivative of that, so just minus s minus c, so this cancels, minus 2 minus 2s e power t. This stuff would just be like minus s plus c plus s, which is 2c, so 2c power t, and then this stuff is once again the same, so square root 2 e power t. Now calculate this at t equal to 0, so basically we just get your v equal to t equal to 0, so the sign thing does not really matter, so it's just 1 1 square root 2, and your acceleration just happens to be, this thing is 0, this thing is 1, so it's just 2, so 2 square root 2 over there. Cool. Now your what do we want to find? So this, I guess so just v dot a upon magnitude of v, that's the thing. So what's that gonna be? Well, this is 0, this is 2, 2 plus 2 is 4, so 4 upon the magnitude of v is just square root of 1 plus 1 plus 2 is 4, so this thing is just 2, so this thing is 2, so your tangential acceleration is 2. What about the normal acceleration? I'll take a v cross a thing, so it's just 1 1 square root of 2 crossed with 2 square root of 2, which you can think of as like just taking square root outside, like just becomes 0 square root 2 1. So this is just square root 2 times, what is this stuff? So it's just 1 minus of 2 is minus 1, then you go 0 minus 1 is minus 1, and then square root 2, I suppose, right? So we want the magnitude of this stuff, which is like square root 2 times square root of 2 plus 1 plus 1, which is 4, so this 2, so 2 square root 2, so 2 square root 2 upon the velocity, which is also just 2, so it's square root of 2, so this thing would just be square root of 2, it seems. Sure, yeah, I guess that's the way it is. Next, the seventh question is in exercise 7 and 8, find RT. Okay, the whole thing, then find the equations for oscillating normal and rectifying planes at the value of t. Sure, so first you just want the velocity. The velocity is just minus sine comma cosine comma, well, just minus 1, so 0. Your acceleration would just be like negative cosine comma negative sine comma 0. So what we want is your t basically. Actually, we don't really care about the acceleration at this point, so forget that. So your t is the same thing as your v apparently, so just t equal to v. So your t dot is the same thing as your acceleration, which is just negative cosine comma negative sine comma 0. So your normal is the same thing as this, in fact, because it's a unit vector. What we want is the binomial vector. So binomial vector is just this t cross n thing, which is just let's figure it out. So it's minus sc0 and then crossed with c minus s0, which thing is, so it's minus s, so it's s squared plus c squared is 1, and all of that is like 0 0 obviously. So yeah, it's just 1 0 0. Oh shit, this thing is supposed to be for here. Hey, I didn't do it, never mind, it was just the magnitude in any case, so it wouldn't matter. This is 0 0, so it's completely in a k hat as expected. So this thing is obviously just k hat, or you could just write it as 0 0 1, that's better probably. Okay, now what do you want? You want to find RT and at the given value of small t. Sure, so your R would, so at t equal to pi by 4, so it's just 1 by square root 1 by square root 2 comma negative 1 square root 2 comma 1 by square root 2 comma negative 1. Your t value is just at minus 1 by square root 2 square root 2 comma 0. This thing is just minus 1 by square root 2 minus 1 by square root 2 comma 0, and this thing is obviously 0 0 1, no matter whatever t you have. Okay, at 7th, what is 8th? 8th, once again the same stuff. So at t equal to 0, your r of 0, that's just going to be like what? Well, it's 1 and 0, so just 1 0 0, whatever, none of that really matters. So velocity, hey, it's so the same things before. No, it's slightly different, so it's v equal to minus sine cosine 1. Sure, and your t would just be like 1 by square root 2 of all of this minus sine cosine 1. So your t dot would just be equal to 1 by square root 2 negative cosine comma negative sine comma 0. Okay, cool. So you just have, this is the same. Hey, so this is already not, no, it's not normalized. So your n would just be equal to negative cosine comma negative sine 0 obviously, but yeah. So your binomial vector, that would just be 0 0 1, right? Because this is basically like t cross n, but then yeah, I suppose, but like yeah, sure, so it's just 1, makes sense. No, 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 okay, it's not so easy, unfortunately, this time, because your t is also having a z component. Okay, so t cross n, which is just 1 by square root 1 by just not 1 by square root over there, 1 by square root 2 negative sine cosine 1 that crossed with negative cosine, yeah, negative sine 0, which is like 1 by square root 2, and so this is just like minus plus sine, and then for that you're just doing minus cosine plus 0, so just minus cosine, and then for this stuff it's sine square plus cosine square is 1. Yes, so that's how it is. So binomial vector is known now. Okay, how do I even write this? I'm just gonna take the whole thing, shrink it, and write it down. So your binomial vector is just 1 by square root of 2, and then you got sine minus cosine and then 1. So you want this at what, t equal to 0, right? I suppose yes. So this would just turn out to be what? This would just be like minus. So this is 0 comma 1 comma 1. Your t thing would just be like 1 by square root 2 of 0 comma 1 comma 1, obviously. This stuff would be so t dot, we don't really care about that, so we just care about the n thing. So n thing is just minus cosine comma minus sine, so just minus 1 comma 0 comma 0. This stuff is 1 by square root 2 0 comma minus 1 comma 1. That's pretty much it. 8th is done. Ninth question is in exercise 9 of 16 or 16 you found what, 13.4. okay, in the previous one, so you found t and then kappa. Now in the following, right, find b and tau for these space curves. So beta and tau, the binomial vector and tau. Oh, don't tell me you will have to calculate everything once again. This is some sort of, this is really bad, isn't it? T cross n, huh? Let's see if we can sort of simplify this somehow. Shouldn't there be a better way to be finding binomial vector? Nope, there is no better way. You just have to do t cross n, apparently. No, I refuse to believe this is how it should be. I don't want to do the, don't want to find the t dot thing. Can't you just skip that somehow? The binomial vector. So you can find a torsion pretty easily, but find the binomial vector is like, it's one heck of a thing. It's t cross n, which is like t cross d by dt of, or d by ds or whatever. So just like, what is n? Yeah, so just t dot, normalize that. So 1 upon negative of t dot, that times t dot basically. Now how do I rewrite this? This is velocity upon magnitude of velocity, sure, crossed with 1 upon the derivative of all of that. This is really bad. So dt upon dt, that's just going to be like v dot upon magnitude of v, right? And then minus the velocity vector upon magnitude of v square, and that's the dv by dt thing, which we know is just what? That thing is just a tangential acceleration. Sure, that isn't really useful, right? Oh, but actually that might actually be useful. This is v dot times v upon magnitude of v. That probably would work. Just v square, that cancels with this. Hey, that is 0. That doesn't even make sense. Something is really messed up. It's not working. Okay, this we know. Yeah, I mean, that is the thing, right? Yeah, so the tangential acceleration is just that, but the tangential acceleration is also just a dot t, which is like a dot v vector upon the v vector. So you are saying this is equal to your d magnitude of v upon dt thing. So if I put that over there, and obviously a is just v dot, so that dot with this stuff, so it just becomes like v dot upon magnitude of v minus v dot dot with v vector and then v vector upon the magnitude of v squared and another magnitude of v, just magnitude of v cubed. Yes, essentially that's what you're saying. Okay, so this is your t dot basically, isn't it? Interesting. This is going to be perpendicular to your velocity vector, right? How do you find its magnitude? You do not find its magnitude, isn't that the thing? Right. So you're doing t cross n. T is just this stuff, right? It's just v upon magnitude of v. And you're doing this cross this upon its magnitude. Let's just forget about the magnitude. Okay, what happened? Why did this just switch off? So what I'm thinking is there has to be like some sort of a better way to be doing this, and that's why I'm trying to do all of it. Like, otherwise there's no point. We can just start calculating right away. But yes, I'm thinking what direction might it be going in. So just v cross, so multiply by v squared, so we just have something like v dot magnitude of v squared minus v dot dot v vector and v, something like that, right? Okay, so doing a cross product with v, so this would really just be 0. So it would be something like v cross v dot, so you know, make this into a unit vector basically. So basically like v cross a, this doesn't really matter, so it's just v cross a. Does that make sense actually? I suppose yeah, it should make sense. So beta, oh okay, wait a second, what? Hey, yeah, I mean this should make sense. Because your acceleration, whatever is a tangential component, that's a normal component. So in the end you just get this stuff. I mean that was kind of obvious, but yeah, okay, this actually does make sense. So yes, so you just have to do v cross a, and that actually gives you your b vector, like without having to worry about the whole process. Interesting. And then you also want to find a torsion, which we can just figure out as, well, v, the box product v a, and then the jerk, just call it a dot, and then upon the magnitude of v cross a, yeah, squared obviously. That pretty much does it, doesn't it? I mean, you just have to calculate what this vector is, and then you can just do this stuff. And obviously this determinant shouldn't be that hard, because it's essentially just v cross a, like dot product of this with a dot. So once you know what this vector is, you actually know everything. I see. Yes, that's the formula. So let's actually get to it. So you know where binomial vector is, in fact, like what's its direction, and once you know that, you know everything. So you just have to calculate what v cross a is. Cool. That's actually a nice realization. So let's go. Ninth, we just have r equal to this stuff. So what's your velocity? Velocity is just 3 cosine comma negative 3 sine comma 4. Then your acceleration is just, what is this stuff? It's just, why did this happen? Screen copy. This is very unexpected. This shouldn't have happened. Okay, so right, your acceleration is just what, negative 3 sine comma negative 3 cosine comma 0. I'm just gonna do a cross product over there. So what do you go? You just get this stuff, 3c minus 3s 4, that crossed with minus 3s minus 3c 0, which is this, so it's just 9c square plus 9s square, just 9. That's gonna be over here actually. For this you just do 0, and then so just 12c for this stuff it's just minus 12c, so plus 12s actually, right? So there you go, that's your vector. So your binomial vector is just like divides this basically, like this reduces to 4 and 3, so it's 1 by 5 is what we go for. So it's just 1 by 5 of 4c comma 4s comma, so minus 12s 3. Yes, so we got that. What about the torsion? The torsion would just be like, so you have this quantity, so you just have to do, so you just figure out what a dot is. So a dot would just be, take a derivative of that in fact, so just minus 3 cosine comma 3 sine comma 0. Now take a dot product of that with this stuff. What do you get? You just get 36, negative 36 cosine square, then negative 36 sine square is negative 36, and then that thing is 0, so it's just that, because negative 36 basically. So it's just the negative 36 thing upon the magnitude of, why is this taking so, just gonna kill something like this. Okay, so that's just gonna be like 3 times of 5, so just 3 times of 5, and you also have to take a absolute, so just 12 upon 5. The torsion is just 12 upon 5, and you have your p vector. That's all you need really. That was pretty fast. Come on, just give me this. Okay, 10th is r is given what, the same stuff, the manual vector and all that. So your velocity, this is just a repetition of the previous one, isn't it? So sure, your derivative is just negative sign, that cancels, and then taking a derivative of this stuff is just t cosine. It's t cosine comma t sine comma 0, right? Your acceleration is just, we'll take a derivative of that, so it's cosine sine, and then so it's just c minus st comma s plus ct plus 0. Your a dot, we should really just calling that something. What is the jerk usually called? No idea, but yeah, so this minus s and then minus cosine t, okay, minus 2s minus cosine t, and this stuff is 2 cosine minus sine t comma 0. Okay, cool. So what you want to find is same stuff, so just v cross a, cross with this stuff, right? So it's c minus st, s plus ct 0, which is like what, t, and then you got, so cs, which is 0 0 cs plus c squared t, and then subtract that, so it's minus sc plus s squared t, so it's just t basically. Okay, cool, so you got that. So what's the magnitude of v cross a? That's just equal to t square. What is the box? So v cross a dot, right? What is that quantity? Well, that's a 0 actually, right? So what does it mean? Torsion is 0, and your binomial vector is just, we actually already have it, so binomial vector is just basically like 0 0 1. Yeah, that pretty much does it. So b is 0 0 1, or just k hat, or you could just have 0 0 1 directly. Okay, and your torsion is 0 because it does not really change. Remember, there are thousands of different ways to be defining your vectors. 11th is r equal to this stuff. So velocity is, okay, so velocity is what, divided into this stuff is equal to the number of c minus s that's 2, so that's gonna be gone in any case. So it's s plus c, 0. Your acceleration is just like e power t. You have all of that plus its derivative, so it's c minus minus s minus c. So that c cancels, it is minus 2s. Cosine minus sine, so it's 2 cosine. Right, it pretty much does it. So what do you want? You want v cross a, which is like e power 2t, or you should just actually pull that out. So just 2 e power 2t, and then this stuff c minus s plus c. This crossed with what? This stuff. It's minus s c 0, I suppose. Why does this keep happening? Okay, cool. Which is like what? Oh my god, okay. This is frustrating. Seriously though, why is this actually happening? So this would be what? This would just be 2 e power 2t, and then take a, so just, then I'm just gonna take the k hat thing over there, and then this just comes c square minus sc minus s square plus s square minus sc. This cancels, it's just 1. So it's 2 e power 2t k hat. It's a binomial vector. No, that's not, this is your v cross a. So your b vector is just, well, k hat essentially all the time. So tau is equal to 0 without hesitation, because it involves b dot in any case. So that's gone. Let's go to 12th. 12th is same stuff. Velocity is just what? Now this is getting a bit too familiar, isn't it? Yeah, I mean, all of these are of some particular format. This is a helix, right? It has some torsion. This was at a certain plane. It had no torsion. Look at this, there's no k component, it's completely in a plane. So your binomial vector is pointing upwards. Similarly over here, all of these in fact are just completely in planes, except this last one. The last one is something like a helix. Not exactly. I see, this is actually very weird. So the 12th one is derivative of that stuff. So what do you have? This is just like what? So it's just gonna be like 12 cosine of 2. So this is just so frustrating. This is just so frustrating. Okay, well, this thing is what? This thing is 5. That's a v. Your acceleration is that's actually good. ज़्यादा लोगों का हो जाएगा. मैं तो बस सैमसंग को बुला लिया थी. क्या? कुछ नहीं भाई, वीडियो बना रहा हूँ. और जस्ट ऐसे ही चैनल के लिए. This is just really bad. It's really bad. Why is it so hard to write on this? So what you want is this v cross a, don't you? So that's gonna be like what? 12 times 24, whatever that quantity is. minus 12 c square, and then it's just so minus 12. Right. Okay, so this thing is your v cross a. So with this we can figure out what the binomial vector is. It's in this direction, right? So your b thing would just be like normalize that, so it's 13. So it's like 1 by 13. Then you have 5 cosine negative 5 sine 1 negative 12. And what is your, what was I going to say? What was I going to say? I kind of forgot it. Shit, I really forgot what I was going to say, wasn't I? Wow, I really forgot what. Oh yeah, okay. So we wanted to find a torsion. So the torsion, which is so take a, yeah, okay, that actually makes sense. So there's 1 upon the magnetic velocity, so b cross a thing, which is just like 1 upon 24 times 13, and then from that point onwards we can treat it as a unit vector. So it's just like just have some 1 by 13 times of this vector 5c negative 5s comma 12 minus 12. You can just treat it like that, and then dot product that with a dot. A dot is this stuff, so it's just 48 minus cs and then 0, which is 1 upon, this is, so why is it so hard to write on this? That is 13 squared, and then that times of 48 over there, so this becomes 2. And what is this? So that's just 5, sure. So 5 plus 0, so just 5 over there. So it's 10. So it's 10 upon 13 squared, so it's 10 upon 169. Constant torsion. Your b vector is just this. So it's 5c by 13. This thing is a tau. Okay, cool. Move on. So, just so frustrating. So frustrating. 13. 13th is the same. This is really just taking a lot of time. Oh, you don't even have to worry or anything, because this is just going to be like b equal to k hat, and then your tau is just 0 because it's constant. So in fact for 13 and 14 and 15, all of these have b in k hat. What about 16th? At 16th you have cosine ht minus sin ht all that. So velocity is just, so you have sine comma minus cosine comma 1, and then your acceleration is just gonna kill something. This is happening, I don't know which time this is happening, but yes. So your acceleration is what? Just take a tip. Patience, patience. Stuff happens, it's nothing to be worried about. Okay, now let's just keep going. So cosine negative sine 0, remember it's cos h and sine h, not cosine and sine, by the way. The a dot would just be like sine comma negative cosine comma 0. So what's your v cross a? Suppose you do this stuff, so it's just sine, and then you do this stuff, so just cosine, and then finally do this stuff, it's minus sine square plus cosine square, so it's just 1. Yes, so that's also a binomial vector. No, not exactly, because you have to do the square and all that stuff. Sure. So binomial vector is This is painful, really painful. So just 2 plus 2s squared. Okay, it's just I'm gonna kill something. Just okay, now it's seriously not receptive. So square root of 2, that is, why is it happening? Why is it not? Okay, and then you have SC1 and your tau, that will be, we take a dot product of that with this, so it just turns out to be s square minus c square, which is just minus 1, and that upon the magnitude of v cos a squared, which we know is just, what is it exactly? It's just s square plus c square plus 1 is like to be c square, so it's 2c square. It's minus 1 upon 2c square. That probably, yeah, that actually does it. Sure, move on. So that's 16th. 17th. Alright, you know what, I'm gonna stop here because this is getting out of hand. Like, it's just so hard to control this device, so I'm going to stop here. So I'll see you guys in the next video. Bye. Wow, I can't even draw this. Bye.